Lesson: Quadratic functions and quadratic equations. All over China, parents tell their children to stop complaining and finish their quadratic equations and trigonometric functions because there are 65 million American kids going to bed with no math at all. Michael Cunningham. The three equations of the quadratic function are as follows. 1. The standard form, which is y equals ax squared plus bx plus c, where a, b, and c are real constants. A does not equal 0. The coordinates of the vertex are x vertex equals negative b over 2a, while y vertex is equal to f of x vertex. Then we have the second one, which is the vertex form, which can be represented as y equals a times the quantity x minus h everything squared plus k, where a, h, and k are real constants. A cannot equal 0, and the coordinates of the vertex are x vertex equals h and y vertex equals k. And finally, we have the x-intercept form, which is y equals a times the quantity x minus x1 times the quantity x minus x2. In this case, a is a real constant, a cannot equal 0, and x1 and x2 are the x-intercepts. The coordinates of the vertex are as follows, where x vertex is equal to the average of the x-intercepts, which can be written as x1 plus x2 divided by 2, while y vertex is f of x vertex, same as before. Important. All three forms have three constants that are either given or must be found. In the standard form, we have a, b, and c. In the vertex form, we have a, h, and k. And in the x-intercept form, we have a, x1, and x2. Let's write the equation of a parabola knowing the x-intercepts and a point on the graph. An example. The x-intercepts are negative 4 and 5, and the graph passes through the point of coordinates 6, negative 20. To do this, let's consider the x-intercept form, where y equals a times the quantity x minus x1 times the quantity x minus x2. Substitute the x-intercepts. Y equals a times the quantity x plus 4, because we have x minus x1 minus negative 4, positive 4, times the quantity x minus 5. Substitute the coordinates of the point of coordinates 6, negative 20 into the equation above. Thus, negative 20 equals a times the quantity 6, positive 4 times the quantity 6, negative 5, which is equivalent to negative 20 equals 10a. Divide both sides by 10 to achieve the equivalent statement, a equals negative 2. Thus, y equals negative 2 times the quantity x positive 4 times the quantity x negative 5, which is the equation of this parabola in x-intercept form. Now, let's write the equation of a parabola knowing the vertex and a point on the graph. An example of that would be that the coordinates of the vertex are point of coordinates -1, -4, and the graph passes through the point of coordinates 2, 5. So let's see how that plays out. Let's consider the vertex form where y equals a times the quantity x negative h, everything squared, plus k. Substitute the coordinates of the vertex in here. Straightforward. H is -1, so we have y equals a times the quantity x plus 1, everything squared. K, -4, substitute that right in. Now, we want to substitute the coordinates of the point 2, 5 into the equation above. Thus, 5 equals a times the quantity 2 plus 1, everything squared, minus 4. Now that we have all of this, let's solve for a. That's equivalent to 5 equals 9a minus 4. 2 plus 1 is 3, 3 squared is 9. Which is equivalent to 9 equals 9a, divide both sides of the equation by 9, equivalent to a equals 1. Now we go back and plug in everything we know into that vertex form. Thus, y equals x plus 1, everything squared, minus 4, which is the equation of the parabola in vertex form. Now, let's try writing the equation of a parabola knowing the coordinates of 3 points on the graph. An example of this would be that the parabola passes through the points of coordinates 0, -3, 1, -2, and 2, 3. So let's consider the standard form. Y equals ax squared plus bx plus c. Substitute the coordinates of each of these points into the equation above. So first we're going to deal with the first point, 0, -3. -3 equals a times 0 squared plus b times 0 plus c. Thus, from this equation alone, we can determine that c equals -3. Now let's try the second point. Substitute -2 in for y and 1 for x. So -2 equals a times 1 squared plus b times 1 minus 3. This is equivalent to a plus b equals 1. Let's continue on with the last point. Substitute y as 3 and x as 2. 3 equals a times 2 squared plus b times 2, -3. This is equivalent to 4a plus 2b equals 6. Now let's divide both sides of this equation by -2, which is equivalent to -2a b equals -3. Now why do we do that? We set ourselves up to add the two equations to eliminate one of the variables. So add the equation a plus b equals 1 to the equation -2a b equals -3. And by doing this, you obtain -a, and then the b's cancel out, equals -2. Dividing both sides of the equation by -1 results in a equals 2. Now we can substitute a equals 2 into our equation a plus b equals 1. Thus, 2 plus b equals 1, equivalent to b equals -1. Now that we know a, b, and c, we can go back to the standard form and substitute that all in to obtain y equals 2x squared negative x, negative 3, which is the equation of the parabola in standard form. Now, let's find the coordinates of the vertex of a parabola given that we know its standard form. Example, f of x equals 3x squared, negative 6x, negative 5. The coefficients of the standard form are as follows. A equals 3, b equals negative 6, and c equals negative 5. We know x vertex to be equal to negative b over 2a, which is equal to negative 6 over 2 times 3, which equals 1 after performing calculations. Now to calculate our y vertex, we simply plug our x vertex into the function f of x vertex, which is f of 1, which equals 3 times 1 squared, minus 6 times 1, negative 5, which equals 3, negative 6, negative 5, which equals negative 8. Thus, the coordinates of our vertex are point of coordinates 1, negative 8. Now, if we want to find the coordinates of the vertex of a parabola, given that we receive it in vertex form, what do? Well, let's check out an example. This example, f of x equals 3 times the quantity x plus 4, everything squared, minus 7. The vertex form is written as f of x equals a times the quantity x negative h squared plus k. Thus, when we put these right underneath each other, we can see h equals negative 4 because negative h is represented by a positive 4. Likewise, k equals negative 7 because negative 7 represents k in our example. Thus, the coordinates of the vertex are negative 4, negative 7. Simple as that. Now let's find the coordinates of the vertex of a parabola given in x-intercept form, where f of x is equal to 3 times the quantity x positive 4 times the quantity x negative 6. So, the x-intercepts are as follows. Negative 4 and 6. X vertex is the average of these two x-intercepts. So x1 plus x2, everything divided by 2, which is equal to negative 4 plus 6, divided all by 2, equals 2 over 2, which is 1. X vertex equals 1. Y vertex is found by finding f of x vertex. So in this case, f of 1. F of 1 is 3 times the quantity 1 plus 4 times the quantity 1 minus 6. We've substituted that 1 everywhere we see an x. Now let's do our performing of calculations. 3 times 5 times negative 5, which results in negative 75. Thus, the coordinates of the vertex are 1, negative 75. After doing that, let's jump straight into some applications to test what we've learned. Question 1. The graph of the quadratic function f, where f of x equals a times the quantity x minus 4 times the quantity x plus 10, is a parabola. If the minimum value of the function is negative 21, what is the value of the constant a? In order to find the value of the constant a, we must write an equation with the variable a. we have the x-intercept form of the parabola. It's given. The x-intercepts are thus 4 and -10. X-vertex is equal to the average of the x-intercepts, and thus is x1 plus x2 divided by 2, which is 4 minus 10, everything over 2, which equals -6 over 2, which equals -3. Now, our y-vertex is f of x-vertex, which is f of -3, which equals a times the quantity -3, -4, times the quantity -3, +10, which equals a multiplied by -7 multiplied by 7, which equals -49a. The coordinates of the vertex are -3, -49a. But the minimum value of a quadratic function occurs at its vertex. And the minimum value of the function is -21. Thus, -49a is equal to -21. This is a linear equation with the variable a, and we can divide both sides of this linear equation by -49 to solve it. Thus, a equals -21 divided by -49. We can reduce this fraction by -7, resulting in a equal to 3/7. Question 2. In the xy plane below, the parabola y equals ax squared, positive bx, positive c, has the x-intercept point of coordinates 4, 0, and the y-intercept point of coordinates 0, 9. What is the sum of the constants a and c? So we're given the standard form of the parabola. The parabola has only one x-intercept on the x-axis, and the x-intercept is also the vertex of the parabola in this case. So let's consider the vertex form of the parabola. Y equals a times the quantity x negative h, everything squared, plus k. And substitute the coordinates of the vertex into that equation. So y equals a times x minus 4 everything squared, because 4 is our h, it's the x coordinate of the vertex, plus 0, its point of coordinates 4, 0, 0 is our y coordinate, thus it is k. To find the value of the constant a, we will substitute the coordinates of the y-intercept into the equation above, because it's another point that we can use to solve for a. So, point of coordinates 0, 9, substitute 9 for y, 9 equals a times the quantity 0, negative 4, everything squared. Equivalent to 9 equals 16a. Divide both sides of the equation by 16, thus a equals 9 divided by 16. To find the value of the constant c, we can substitute the coordinates of the y-intercept, 0, 9, into the standard form of the quadratic function. 9 is equal to a times 0 squared plus b times 0 plus c. Thus, c equals 9. From that, we can find the sum of the constants a and c, which is 9 plus 9 over 16, which equals 9 and 9/16. Question 3. The equation of the line tangent to the graph of a parabola is y equals 4x plus 6. If the maximum value of the quadratic function is 8 at x equals -1, what is the equation of the function in standard form? The maximum value of a quadratic function occurs at its vertex. Thus, we will consider the vertex form of the quadratic function. Y equals a times the quantity x minus h, everything squared, plus k. We wrote that the maximum value of the quadratic function is 8 at x equals -1. Thus, h equals -1, the x coordinate, and k equals 8, the y coordinate. Substitute these values into the vertex form. Y equals a times the quantity x plus 1, everything squared, negatives cancel out, plus 8. The equation of the line tangent to the graph of a parabola is y equals 4x plus 6. A line and a parabola can have no points of intersection, 1 point of intersection, or 2 points of intersection. A line tangent and a parabola have only 1 point of intersection, as shown in this example. They touch once at that red dot. Thus, the system of equations made by the equations of the two curves should have only one solution. Let's apply the transitive property of equations. Thus, a times the quantity x plus 1, everything squared, plus 8 equals 4x plus 6. The quadratic equation with the variable x must have only one solution. Thus, its discriminant must be 0. To find the discriminant, we have to first write this equation in standard form. Apply the binomial square formula to expand this binomial into a trinomial. So that's equivalent to a times the quantity x squared plus 2x plus 1 plus 8 equals 4x plus 6. Then we can apply the distributive property of multiplication over addition, which is equivalent to ax squared plus 2ax plus a plus 8 equals 4x plus 6. Now, we'll add negative 4x and negative 6 on both sides of the equation, equivalent to ax squared plus 2ax minus 4x plus a plus 2 equals 0. Then we would want to factor 2x from the like terms, positive 2ax and negative 4x, equivalent to ax squared plus 2x times the quantity a minus 2. Multiplication is commutative, thus we can change the order of factors, swapping our x and a negative 2 around. Plus a plus 2 equals 0. Now we want to use the half quadratic formula to find a discriminant. The coefficients are a equals a, b prime, which is half b, is equal to a negative 2, and c equals a positive 2. The discriminant prime is equal to b prime squared minus ac. which equals a negative 2 everything squared minus a times a positive 2. We want to expand the binomial into a trinomial here. A squared minus 4a plus 4. And then we applied the distributive property of multiplication over addition. Negative a squared, negative 2a. Now, group like terms to beautify this statement. A squared, negative a squared, cancel out. Negative 4a, negative 2a are like terms, thus discriminant prime is equal to negative 6a, positive 4. The discriminant prime, as we stated earlier, has to equal 0 for there to be one solution. Thus, negative 6a plus 4 equals 0, which is equivalent to negative 6a equals negative 4. Divide both sides of this equation by negative 6 and obtain a equals 4 divided by 6, which is equivalent to a equals 2/3. Thus, the equation of the parabola in vertex form would be y equals 2/3 times the quantity of x positive 1, everything squared, plus 8. To write this equation into standard form from our vertex form, let's expand the binomial into a trinomial using the binomial square formula. Y equals 2/3 times the quantity x squared plus 2x plus 1, everything plus 8. Apply the distributive property of multiplication over addition. Y equals 2/3 x squared, positive 4 over 3x, positive 2/3, positive 8. Perform calculations between like terms. Thus, the equation of the function in standard form is y equals 2 over 3x squared plus 4 over 3x plus 26 over 3. Question 4. 4 plus root 15, everything over x plus 1, equals x divided by 4 negative root 15. The rational equation above has rational roots because a, the coefficients are irrational, b, the discriminant is positive, c, the discriminant is a real number, d, the discriminant is a composite number, or e, the discriminant is not a perfect square. The domain of the equation is the set of real numbers minus the set made of negative 1. The irrational equation here is a proportion. So let's apply the cross product property of a proportion. The product of the means is equal to the product of the extremes, which results in x times the quantity x positive 1 equals the quantity of 4 positive root 15 multiplied by the quantity 4 negative root 15. Let's apply the distributive property of multiplication over addition. Equivalent to x squared plus x, and then we compress the special product into difference of squares on the right side of this equation, which equals 16 minus 15. Performing calculations, equivalent to x squared minus x equals 1. Subtracting 1 on both sides of the equation, results in an equivalent x squared minus x negative 1 equals 0. Now, let's solve the quadratic equation using the ABC discriminant formula. A equals 1, B equals negative 1, and C also equals negative 1. Delta is equal to b squared minus 4ac, which equals negative 1 squared, negative 4 times 1 times negative 1, which equals 1 plus 4. Thus, the delta is equal to 5. 5 is a prime number, not a composite number. Thus, statement D is a false statement. Likewise, statement A is also false. For example, square root of 2x equals 4 square root of 2 has irrational coefficients, but the root 4 that will result from this is still rational. Statements B and C are also false. For example, x squared equals 9, equivalent to x equals plus or minus 3. The discriminant 9 is a real positive number, and the roots are rational. In conclusion, the roots are irrational because the discriminant is not a perfect square. 5 is not a perfect square. The correct answer is thus E. Question 5. True or false? The parabola below has no x-intercepts for all real values of the constant k. Y equals 2x squared, positive 2, times the quantity k plus 1, positive k squared, positive 2. A parabola has no x-intercepts if and only if the quadratic equation y equals 0 has no real roots, which is equivalent to the discriminant is negative. So let's use the half formula to find a quarter of the discriminant. A equals 2, b prime equals k plus 1, b prime half of b. C equals k squared plus 2. Our discriminant prime is equal to b prime squared minus ac, which is equal to k plus 1, everything squared, minus 2, times k squared plus 2. Let's use the binomial square formula to expand this binomial square into a trinomial. K squared, positive 2k, positive 1. Then we'll apply the distributive property of multiplication over addition. Negative 2k squared, negative 4. All right, now group like terms are k squares. K squared, negative 2k squared results in negative k squared. Positive 2k, positive 1, negative 4 results in negative 3. Our discriminant prime is equal to negative k squared, positive 2k, negative 3. We must show that the discriminant squared is negative for all real values of the constant k. Factor a negative 1 from the first two terms. So the discriminant prime is equal to negative the quantity k squared negative 2k, negative 3. To complete the square inside the parentheses, add and subtract a 1, equal to negative the quantity k squared minus 2k, positive 1, negative 1, outside negative 3. Distribute the negative sign to the group of the first three terms. Then we distribute the negative sign to the fourth term of the parentheses. So we have negative the quantity k squared negative 2k positive 1 plus 1 minus 3. Then we can compress this trinomial into a binomial square equal to negative the quantity k minus 1, everything squared. Group the like terms of positive 1 and negative 3, negative 2. Now, k negative 1, everything squared, is greater or equal to 0 for all k belongs to R, the set of real numbers, which is equivalent to saying that the negative of the quantity k negative 1, everything squared, is less or equal to 0 for all k belongs to the set of the real numbers. Now, let's add a negative 2 on both sides of the inequality. Negative the quantity k negative 1, everything squared, minus 2 is less or equal than negative 2. Thus, discriminant prime is always less than 0. Thus, the parabola has no x-intercepts. Question 6. The xy plane on the left shows two x-intercepts and the y-intercept of the parabola. If a line passes through the vertex of the parabola and the x-intercept point of coordinates 2, 0, which of the following must be the y-intercept of the line? And we have a few options here. So let's get directly into solving this question. To find the y-intercept of the line, we must find the equation of the line. The equation of a line is determined by 2 points on the line, or a point on the line and its slope. It is given that point of coordinates 2, 0 belongs to the line. It is also given that the line passes through the vertex. In order to find the coordinates of the vertex, we must have the equation of the parabola. The x-intercepts of the parabola are given, and we can look at the graph for that. Point of coordinates negative 4, 0, and point of coordinates 2, 0. Let's substitute them into the x-intercept form, where y equals a times the quantity x minus x1 times the quantity x minus x2. Substituting them, we obtain y equals a times the quantity x plus 4 times the quantity x minus 2. Also, the y-intercept, point of coordinates 0, 16 over 3, is given. Substitute its coordinates. 16 over 3 equals a times the quantity 0 plus 4 times the quantity 0 negative 2. This is equivalent to 16 over 3 equals negative 8a. Divide both sides of the equation by negative 8, equivalent to a equals negative 2 everything over 3. Thus, the equation of the parabola in the x-intercept form is y equals negative 2 over 3 times the quantity x plus 4 times the quantity x minus 2. X vertex is the average of the x-intercepts. So, x1 plus x2, everything divided by 2. Negative 4 plus 2, everything divided by 2, which equals negative 2 over 2, which equals negative 1. Now y vertex is equal to negative 2/3 times negative 1 plus 4 multiplied by negative 1, negative 2. We substituted our x vertex into the equation of the parabola. Evaluating this, we get negative 2/3 times 3 times negative 3. We can cancel out the 3 at the bottom and the 3 at the top and get an answer of 6. We have now 2 points on the line. Vertex of point of coordinates negative 1, 6, and point of coordinates 2, 0. The equation of a line through 2 points is y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. So let's get to plugging in. Therefore, y minus 0 over x minus 2 equals 6 minus 0 over negative 1 minus 2. This is equivalent to y over x minus 2 equals 6 over negative 3, which equals negative 2. The equation of the line. There's no need to write this equation in slope-intercept form. To find the y-intercept, it is sufficient to substitute x in here by 0. Thus, y over 0 minus 2 equals negative 2. Thus, the answer is C, 4. Question 7. If a parabola passes through the points, point of coordinates negative 2, 3, 1, 7, and 4, 3, then the sum of the coefficients of the quadratic function is equal to a3, b4, c negative 2, d7, or e. Cannot be determined. Let's consider the standard form of the quadratic equation. Y equals ax squared plus bx plus c, where a, b, and c are the coefficients. The point 1, 7 belongs to the parabola. Thus, 7, we replace our y with 7, equals a times 1 squared plus b times 1 plus c. Thus, 7 equals a plus b plus c. A plus b plus c is the sum of the coefficients of the quadratic function. Thus, we have our answer, 7, D. The correct answer is D. Question 8. Always, sometimes, or never. Any 3 distinct points define a unique parabola that passes through those points. Case 1. The 3 points are collinear. If the points are collinear, then they lie on a straight line. A parabola is not a straight line. Thus, 3 collinear points don't define a parabola. In conclusion, we can say that the statement cannot always be true, so let's cross that off. Case 2. The 3 points are non-collinear. An example of 3 points that uniquely define a parabola is sufficient to prove that the statement is sometimes true. Because that's our one time. It could be more times, could be less. Doesn't matter. Sometimes. Example. Let's take the points, point of coordinate 0, 0, negative 1, 1, and 1, 1 that belong to the parabola. Substitute the coordinates of the points into the standard form of the quadratic equation y equals ax squared plus bx plus c. So, taking the first point, 0 equals a times 0 squared plus b times 0 plus c. Thus, c equals 0. Now the next point, 1 equals a times negative 1 squared plus b times negative 1. Thus, a minus b equals 1. Now our last point, 1, 1. 1 equals a times 1 squared plus b times 1. Thus, a plus b equals 1. Now we add these two equations together. The b's cancel out, and we obtain 2a equals 2. Divide both sides by 2. A equals 1. Thus, b equals 0, because we can take that a and plug it into one of those equations. A plus b equals 1. 1 plus what equals 1? 0. Alrighty, we have all of our coefficients. Thus, the equation would be y equals x squared. Important. The x and y intercepts are points. Thus, they have two coordinates. However, sometimes, for example, we simply say the x-intercept 3 or y-intercept 3. Still, in all free responses, the x and y intercepts should be written with both coordinates. The end.